When we talk about indoor air quality, we talk about fresh air supply, which is easy to understand. We talk about filtration of the fresh air that we bring in. We also talk about air tightness of the building because that keeps the pollution out. And then avoidance of motor condensation, as well as other indoor air quality goals. Looking at the ventilation rates required by building standard, we talked about the international residential code, which applies to the ICC and the Pretty Good House. Then ASH 362.2 is adopted by California Title 24, Energy Star, and the DOE Zero Energy Ready Home. Fuse has its own requirements. We're going to see those stars in a second, which is the maximum for Fuse is the maximum between the calculated supply and extraction. And then PHI has its own requirements and the maximum between supply, extraction, and volumetric. ASH 62.2 assumes the number of occupants is the same as the number of bedrooms plus one, whereas Fuse assumes that the number of occupants is the same as the number of bedrooms. That's it. For the study for PHI, we are actually showing the airflow rates that we, EMU, specified for those projects because it's a blend between supply, extraction, and volumetric. This is what it looks like. Again, smallest project at the top, largest project at the bottom. Don't need to dive too much into the numbers. More interestingly is looking at the airflow rates per occupant. This is a much more interesting table, which is very small font, so it's impossible to read. That's why we have a graph. Let me skip forward a little bit. We used standard EN 13779 to determine the expected quality of air based on carbon dioxide, so CO2, and occupancy. So the assessment in the standard is based on CO2 levels. It does not account for air filtration, nor does this account for the air tightness of the building, nor does that account for other air quality parameters, which we're going to see later. But it is one of the parameters, so how much fresh air we bring in per person into the building. So this was the average of this project. Now, something that is very important here is that the way we modeled the code minimum, IECC, is actually very generous with building code. If you look at the left-hand side, here we see 12.4 with the solid white circle. And that is assuming fresh air ventilation, continuous fresh air ventilation, which regular energy code or building code does not require. If we have only extraction only from the bathrooms, the air quality is way lower. If you look at the bottom left of this graph, there's the 2.1 cubic feet per minute of fresh air supplied in average per person over 24 hours if you're just bringing in air by using your bathroom fans. You know, a lot of homes are set up that way because that is what the minimum code is. But to compare apples to apples, we look at, let's assume the IECC has the continuous ventilation. And even with the continuous ventilation described by the International Residential Code, we still get low quality of air based on CO2 consumption, CO2 estimation. So this was worth pointing out because it's important in trying to understand how we can get better indoor air quality in our buildings. Now, looking at filtration, we talked about how much air we're bringing in. Bringing in air from the outside brings in pollution, especially if we are living in cities. So we looked at the minimum requirement for each building standard for filtration of the air coming in. This is what it looks like. So the IRC and IECC don't have actual filtration requirements. California Title 24 actually has a very good requirement for filtration because it requires a MERV 13 filter. MERV 13 filters out more than 50% of the smallest particle, the 0.3 to 1 micron in diameter. It filters out 85% of the medium-sized particle, 1 to 3 micron in diameter. And this is the very important one when we talk about cancer and pollution, because particulate matter 2.5 falls in this middle column, the 1 to 3 micron in diameter. And then it filters out 90% of the larger particles, 3 to 10 microns in diameter. So California Title 24 actually has the same filtration requirement as PHI, the International Passive House Institute. So that's very good. Energy Star is pretty bland. I only found a MERV 6 requirement for Energy Star. I hope I'm wrong, but that's what I found. The DOE Zero Energy Ready requires a MERV 8, which filters out only 20% of the particulate matter 2.5, the 1 to 3 micron in diameter, and 70% of the larger particles, 3 to 10 particle in diameter. Now, of course, you can have tighter filters. You can have a higher filtration grade on zero energy ready home projects, but this is what the standard actually requires. And same goes with Fuse. Fuse has the same MERV 8 requirement, which only filters out 20% of the particulate matter 2.5. Whereas PHI, both low energy building and passive house, require the MERV 13, that is, has the greater filtration grade, and it filters out about 85% of that particulate matter 2.5, same as California Title 24. So this is something that I looked into specifically for the study and I found most illuminating, because it does make a difference in the indoor air quality that we can expect in terms of particulate matter and cancer-leading particles. This picture shows a brand new MERV 13 filter, and then the MERV 13 after 3 months in use. You can see how much pollution it has filtered out. So filtration of air coming in is as important, in my opinion, as the quantity of air that we bring in. Then the building being airtight is a contributing factor to the indoor air quality. Basically, you keep the pollution out and you just bring it in and you filter it. This study comes from Australia. Cameron Monroe monitored the exposure of building occupants during a wildfire near Melbourne, Australia. The blue line shows the exterior concentration of particulate matter 2.5. We care about particulate matter 2.5 because it causes cancer. And what he found that in his building that he retrofitted to the NFIT standard, being much more airtight, people were a lot less exposed to particulate matter. So that was significant. Similarly, this is a video published on the Accelerator and YouTube. During the Marshall Fire in Colorado, buildings being airtight were more protected from smoke damage. And so there's an example of a homeowner talking about how he spent years past air sealing his house. He's a passive house professional. And when the Marshall Fire happened, his neighborhood was impacted by smoke, not by fire. And they could move in, I think, the next week or the next day, while all of their neighbors had to have smoke damage mitigation because they were leaky and pollution was able to come in. So air tightness is a significant contribution to buildings being airtight. Avoidance of mold and condensation is critical. Most standards, all the building standards that we considered, have measures to prevent interstitial condensation that happens within the walls. And that is not what we are seeing in this picture. These pictures are showing surface mold and condensation happening at the surface, not inside. And we're going to see later a little bit more what we talk about that in terms of durability. PHI has hard requirements for this, in that they require ISO 13788. Fuse partially. Fuse also accepts other condensation verification methods such as the NFRC condensation resistance and the AMA 1503 methods, which are not really they're not really that strict in avoiding surface mold and condensation. So we gave a partial credit to Fuse because of that. And all other standards, or none of the other standards, have anything to prevent mold and condensation happening on the interior surfaces because they don't require analytical verification of that. Lastly, this is what we mentioned in a previous video. The Indoor Air Plus program by the EPA is a checklist to improve the quality inside the buildings in terms of controlling moisture, radon, preventing pest intrusion, having HVAC system that work better, avoiding pollutants from combustion, and from material finishes. So this is a checklist that is required by the DOE Zero Energy Ready Home as well as Fuse. So we gave credit to this standard for implementing this. So in scoring the standards, this is what it looks like. The coverage of fresh air need is airflow rate per person, supply building occupants with fresh air. Air leakage reduction is reduction compared to the 2018 IECC, and it prevents exterior pollutants from entering the building. Minimum air filtration is filtration grade required by the building standard. It filters out pollutants coming into the building through the continuous ventilation system. And avoidance of mold and condensation, avoidance by design by means of an analytical method, the ISO 13788 or the Canadian CSA A404.2, and then the EPA Air Plus, it protects occupants from other airborne risks. And this is what it looks like in terms of indoor air quality score overall.